Badwar. Today we are discussing the third semestral fluid mechanics topic. The various contents today, first of all introduction, then classification of channels, flow through open channels, comparison between open channel flow and pipe flow, uniform flow through open channels, hydraulic mean depth, hydraulic gradient. Then discharge through open channel by Chase's formula, Bazin's formula, Coutil's formula. Then next, most economical rectangular sections, trapezoidal sections and circular sections. Then losses in the open channels, after that hydraulic jump, and the last one is effects, backwater curve and certain numericals. First of all, certain in the introduction portion of the flow through open channels. In the case of channel, flow of water surface itself is the hydraulic gradient line. The total energy line lies at a distance of V square divided by 2G above the hydraulic gradient line at every section. As the pressure on the top surface of the water in the channel is a constant, no pressure difference can be built up between any two sections along the channel. So, in order to overcome resistance and to cause the flow of water in a channel, it is constructed with its bottom sloping towards the direction of the flow. So, that a component of the weight of the flowing water in the direction of the flow is developed, which causes the flow of the water in the channel. So, it is very important that a component of the weight of the flowing water, a component of flowing water in the direction of the flow is developed, which causes the flow of the water in the channel. Then in the next topic we will discuss the classification of different type of channels. Now, the channels may be classified as 3-4 types. The first one, second, third and so on. The first one, on the basis of cross sectional area of the channel. First is on the basis of cross section of the channel. Second one, on the basis of cross section of the shape. Third one is the open and covered channel. The first one is once again on the basis of the cross section of the channel. First one is of this type is natural channels. Examples दिए हैगियां ने अपने कोल जिस तरह के rivers ने, streams ने etc. The second one of this is the artificial channels, जिस तरह के अपने कोल examples ने canals ने, drains ने and sewers ने. The second one is on the basis of cross sectional shape. It is further classified into two types. The first one is channels of uniform cross section, जिस तरह के साडे कोल examples ने channels या canals of a triangular shape, trapezoidal shape or the circular shape. The second one is channels of this type is channels of the non-uniform cross section. Non-uniform cross section जिस तरह के साडे कोल examples ने rivers ने, streams ने etc. The third one is the open channels, जैसे कि हमारे पास rivers, canals and drains etc. And of second type of this is covered channels, जिनमें के साडे कोल pipes ने, sewers ने, which are not running full. The condition is that they are not running full. Now, flow through open channels. Now, let us discuss the flow through open channels. When water flow take place through a passage of any size and shape such that its free surface is in contact with atmosphere, it is referred as flow through open channel. Now, what do we mean by flow through open channel? So, open channel ਦਾ ਮਤਲਬ ਇਹੀ ਹੈ ਕਿ ਜਦੋਂ ਸਾਡੇ ਕੋਲ ਇਸ ਦੀ free surface ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਉਹ ਕਿਸੇ ਪ੍ਰੈਸ਼ਰ ਦੇ ਨਾਲ ਨਾ ਹੋਵੇ, ਉਹ ਆਪਣੇ ਪਾਸ ਜੋ ਐਟਮੋਸਫੀਅਰਿਕ ਪ੍ਰੈਸ਼ਰ ਹੈ ਉਸ ਦੇ ਨਾਲ ਕੰਟੈਕਟ ਕਰਦਾ ਹੋਵੇ। ਸੋ ਮੀਨਸ that once again we repeat is when flow take place through a passage of any size and shape such that its free surface is in contact with atmosphere is referred as flow through open channels. An open channel is a passage through which water flows under the force of gravity and atmospheric pressure. Now, in this case of the channel, the flow does take place through the under the effect of gravity. The second one is with atmospheric pressure. So, means that an open channel, so we say an open channel is a passage through which water flows under the force of gravity. So, this is a natural gravity which can be maintained by the upstream and the downstream by certain gradient and under the atmospheric pressure. Under the atmospheric pressure means this is not covered one. A channel may be covered or open at the top. Flow of water in an open channel is not due to any pressure, as in the case of the pipes which we have discussed earlier, that the flow through pipe is under pressure, but in this case of the channel it is not under pressure, it is under the atmospheric pressure, but it is due to the slope of the bed of the channel. So, it is very important is that in case of the channel, that the flow is under the effect of the slope of the bed of the channel. So, during the construction of a channel, a uniform slope in its bed is provided to maintain the flow of water. So, it is very important is that during the construction of a channel, a uniform slope in its bed is provided to maintain the flow of water. So, there may be the different type of the shapes, there may be a circular one, there may be a trapezoidal one, there may be a rectangular one. The channels, it may be a circular one, it may be a trapezoidal one, or it may be a rectangular one. Certain features we are getting to discuss. The next topic is we are discussing the comparison between the pipe flow and the open channel flow. First, we are taking the certain features which we can say that certain salient features of pipe flow. The first one is flow is due to the hydraulic pressure. So, it is very important is that the flow in the pipe is due to the hydraulic pressure. Pipes are generally round in cross section. The third one is roughness coefficient depends upon the material of the pipe. The third one, the datum head and the pressure head, where P is the pressure in the pipe and the hydraulic gradient line does not coincide with the water surface. So, in this case of the flow through pipes, the hydraulic gradient line does not coincide with the water surface. And the last one is maximum velocity will occur at the center of the pipe. So, in case of the pipe, the maximum velocity of the flow of the liquid. So, it is very important is, as we have discussed earlier, the maximum velocity of the flow of the water, it occurs at the center of the flow of the pipe. Now, let us discuss certain features of a flow through an open channel. So, the gravity flow. So, the open channel means gravity flow. Gravity flow provided by sloping bottom, that is the surface of the flow of the is made certain slanting towards the downstream side, that is known as the gradient. It may have any shape. The channel, it may have any shape, that is it may be a triangular, it may be a rectangular, it may be a trapezoidal, or it may be a circular one. So, it means that the channel may be of any shape, whereas the pipe are of a circular shape. The third one is varies between wide limits. The hydraulic roughness varies with the depth of the flow. And the next one is that the datum Z plus D, where D is the depth of the flow and the hydraulic gradient line coincides with the surface of the water. So, in case of the open channel, the hydraulic gradient line coincides with the surface of the water. And the last one is maximum velocity occurs at a little distance below the surface of the water. Now, in this case we find that the maximum velocity of the flow of the liquid, it occurs just at the top of the surface of the flow of the water, or we can say that a very little distance from the top surface of the water. Now, let us take the uniform flow through an open channel. Let us take uniform flow through an open channel. Under what conditions the flow is uniform? Let us discuss. The flow in a channel is said to be uniform if the depth, second one, cross section and the velocity remains constant over a given length of the channel. So, means that the flow is said to be a uniform flow in a channel if the depth, cross section and the velocity remains constant over a given length of the channel. Means dV divided by dt is equal to 0. At the same time, the distance, which is means that dd divided by dt is equal to 0. The uniform flows are possible only in case of a prismatical channels, whereas water flow in an open channel resistance is offered to it, which results in the loss of energy. The resistance encountered by the flow of the water is generally counteracted by the component of gravity of the force acting on the body of water in the direction of motion. As we have already discussed, the uniform flow will be developed if the resistance is balanced by the gravity forces. The depth of the flow, wetted area, velocity of the flow and discharge are constant at every section. So, a uniform flow is that one in which the depth of the flow, wetted area and the velocity of the flow and discharge are constant at every section. So, along the channel, the total energy line, water surface and channel bottom are all parallel. That is, slopes are all parallel. So, in case of the hilly region, the gradient available is more than the head losses due to friction, and the velocity of the flow tends to increase, resulting in decrease in depth. This also gives rise to a non-uniform flow. Now, we come the next topic is hydraulic mean depth. So, what is hydraulic mean depth? So, hydraulic mean depth means it is the ratio of the cross-sectional area of the flow. It is the ratio of a cross-sectional area of the flow to the wetted perimeter. So, hydraulic mean depth means it is the ratio of cross-sectional area of the flow to the wetted perimeter. It is also known as hydraulic radius. So, the hydraulic mean depth is the second naam ਅਸੀਂ ਕਹਿ ਸਕਦੇ ਹਾਂ, that is known as the hydraulic radius. It is denoted by certain letters by a small m. So, hydraulic mean depth ਨੂੰ ਅਸੀਂ small m ਦੇ ਨਾਲ represent ਕਰਦੇ ਹੈਗੇ ਆ, ਔਰ small m ਦੀ value ਜਿਹੜੀ ਹੈਗੀ ਆ ਅਸੀਂ ਪਹਿਲਾਂ ਹੀ discuss ਕਰ ਚੁੱਕੇ ਹਾਂ. So, it is equal to the ratio of cross sectional area of the flow to the wetted perimeter. So, means that it is equal to capital A divided by capital P, where capital A means area, capital A means area of the cross section of the flow, divided by P. P means wetted perimeter. P means wetted perimeter, where A is the cross-sectional area of the flow section of the channel, and capital P, it is the length of the channel boundary. We can say wetted perimeter means it is the length of the channel boundary in contact with flowing water at any section. Now, hydraulic mean depth in case of the different sections we will discuss. First, we are getting to discuss in case of a rectangular section. First, we are discussing for a rectangular section. So, hydraulic mean depth जिसनों कि ਅਸੀਂ small m ਦੇ ਨਾਲ represent ਕਰਦੇ ਹਾਂ, which is equal to capital A divided by capital P, means hydraulic mean depth is equal to the area of the flow divided by wetted perimeter. Now, what is A and what is P in case of a rectangular section? Now, this is the flow in case of a rectangular section having the width B and the depth D. So, the area of the wetted, this is equal to B into D divided by perimeter. So, perimeter which is coming the surface in contact, that is the length of the surface in contact, just like this. That is, this is D, this is B and this is D. So, it means that it is equal to B plus 2D, where A is the cross section area of the flow of the channel and P is the wetted perimeter. The second one is hydraulic mean depth for a circular section. Let us say now let us say that this is a circular section. This is a circular section of the diameter D. Now, in this case, the hydraulic mean depth when the circular section is running full. The first condition is that this is a circular section which is running full, that is, it is running full. The hydraulic mean depth in this case, which is as we had discussed earlier, which is equal to the area divided by P, means that the total area of the flow divided by wetted perimeter. Now, in this case, we calculate the area of the flow and the length of the perimeter, which is equal to having a diameter D, that is pi d square divided by 4 divided by the perimeter which is equal to the circumferential length. The circumferential length is equal to 2 pi r, or it is equal to pi into D. Pi into D. Now, when we are getting to solve this one, we find it to be equal to D by 4. So, this comes out to be D by 4 in case of a circular section which is running full, where D is the diameter of the pipe, A is the cross section area and P is a wetted perimeter. Now, let us take the third one case of a semicircular section. This is a semicircular. Semicircular means एक circle the half portion we are making, and this is the diameter of the flow of the loop curve. So, this is a semicircular section. Now, in this case semicircular section, the value of M, hydraulic mean depth, which is equal to A divided by P. A means area of the flow and P means wetted perimeter. So, area which we have already studied, which is equal to pi d square divided by 4, the adha फिर ਆਪਾਂ ਕਰਾਂਗੇ because it is a semicircle. It is a semicircle, total the half, that is pi d square divided by 4 the half means pi d square by 8. And then comes the wetted perimeter. The circumferential total ਦੀ ਜਿਹੜੀ ਹੁੰਦੀ ਹੈ ਸਾਡੇ ਕੋਲ, ਉਹਨੂੰ ਅਸੀਂ ਕਹਿੰਦੇ ਹਾਂ 2 pi r ਜਾਂ pi into d ਦੇ ਬਰਾਬਰ ਕਹਿੰਦੇ ਹਾਂ, ਉਸ ਦਾ ਹੁਣ ਆਪਣੇ ਕੋਲ ਅੱਧਾ ਕਰਨਾ ਪਏਗਾ ਤਾਂ pi d divided by 2. So, when we are getting to solve this one, this equation, then the value of this M, that is the hydraulic mean depth, it also comes out to be D by 4, where D is the diameter of the pipe, A is the cross section area and P is the wetted perimeter. Now, next is the example of a trapezoidal section. Now, this is a trapezoidal section having the width B and the depth is D. This is a base to the depth ratio of n is equal to 1. Now, then we are getting to calculate this length. So, this length is equal to this length the square plus this length the square the under root, means that d square plus nd square the under root, which comes out to be d multiplied by n square plus 1 the under root. Now b is the bottom width of the channel and d is the depth of the flow, n is to 1 is the side slope, that is n horizontal to 1 vertical, then top width this one. So this top one, this comes out to be this one value, this one plus this one plus this one, means that this comes out to be b plus 2 nd. Then this area of this trapezoidal section, which is equal to half the sum of the two parallel sides, these are the two parallel sides, that is this bottom and this top one, half of the sum of the two parallel sides multiplied by the perpendicular distance this one. So when we are getting to substitute and finding this value, it comes out to be d multiplied by b plus nd. So wetted perimeter which is equal to this much value. So the hydraulic mean depth which comes out to be this value, m hydraulic mean depth. Hydraulic mean depth means the area of the flow and wetted perimeter. So wetted perimeter which we have taken is, that is this one plus this one plus this one. So this is 2d ब्रैकेट के अंदर n square plus 1 the square plus b1 and the area which is equal to d multiplied by b plus nd. So this is the value. So this hydraulic mean depth for trapezoidal section, this comes out to be the area of the flow and this comes out to be the wetted perimeter. Now let us take for a circular section which is not running full. Now this is a circular section which is not running full. It means that only this angle 2 theta is running and this is a diameter d which is equal to the 2r. Now area in this case, by means of the geometry when we are getting to solve, this comes out to be r square bracket के अंदर 2 theta minus sin 2 theta divided by 2 and this wetted perimeter. So this one wetted perimeter for angle of 2 theta, this comes out to be 2r theta, and the value of the hydraulic mean depth m is equal to a by p. We substitute the value of a and value of p which comes out to be this relation. Hydraulic gradient. Next topic is hydraulic gradient. For uniform flow, it is equal to the loss of head due to the friction per unit length of the channel. So hydraulic gradient means for a uniform flow, it is equal to the loss of head due to friction per unit length of the channel. It represents the slope of the channel. It is denoted by small letter I. So we find that the hydraulic gradient, it comes out to be HL divided by L, where HL is the loss of head due to friction and L is the length of the flow. Then we come, the next topic is discharge through open channel. So this is the Chazy formula. The first one is Chazy's formula. So laws of governing the flow of the liquid through open channels are similar to those applicable to that of the pipes. According to the frictional resistance, it is proportional to the square of the velocity of the flow. It is proportional to the area of the surface in contact with the flow of the fluid, that is the wetted area. It is independent to the pressure. Now this is, let us take this one where A is this is a channel, certain gradient is provided. Let us take the two sections, the section 1 1 and this is the section 2 2. The gradient is this is the I gradient, where A is the area of the flow, L is the length of the flow, V is the velocity of the flow, where P is the wetted perimeter, F is the frictional resistance per unit area at unit velocity, and I is the uniform slope of the bed of the flow. Now let us calculate the velocity V, which is equal to this one relation. So this we are getting to substitute and find that V is equal to C under the root of Mi, where C is known as the Chazy constant and M is known as the hydraulic mean depth, which is already we have discussed that it is equal to hydraulic mean depth is equal to A divided by P, where A is the cross sectional area of the flow and P is the wetted perimeter. So the discharge by Chasey formula, which comes out to be the area into velocity, we substitute the value of A, we substitute the value of V. So this comes out to be A multiplied by velocity which we have calculated, that is this is equal to C under the root of mi. The value of the Chasey's constant can be obtained by the empirical formulas. Now it is very important is that the Chasey constant, this C, which can be obtained by three empirical formulas. The first one is by Bayesian's formula, the second one is by Coutillard's formula, and the third one is by Manning's formula. Now let us discuss the first one is by the Bayesian's formula. So Bayesian's formula ਦੇ ਮੁਤਾਬਕ ਜਿਹੜਾ ਸਾਡੇ ਕੋਲ Chasey constant C ਹੈਗਾ ਉਹਦੀ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਵੈਲਿਊ ਹੈਗੀ ਹੈ that is equal to 157.6 divided by the whole denominator. So this denominator which comes out to be 1.81 plus k divided by under root m, where this value of C is known as a Chasey constant. So this value is by the Chasey constant by the Bayesian's formula, where m is the hydraulic mean depth, k is the Bayesian's constant, and the value of which depends upon the surface roughness. So ਜਿਹੜਾ ਸਾਡੇ ਕੋਲ ਇਹ k ਦੀ ਵੈਲਿਊ ਹੈਗੀ ਹੈ ਜਿਸ ਨੂੰ ਅਸੀਂ Bayesian's ਫਾਰਮੂਲੇ ਦੇ ਮੁਤਾਬਕ Bayesian's constant ਕਹਿੰਦੇ ਹੈਗੇ ਆ, ਇਹ ਸਾਡੇ ਕੋਲ ਸਰਫੇਸ ਦੇ ਕੰਟੈਕਟ ਦੇ ਉੱਤੇ ਡਿਪੈਂਡ ਕਰੇਗਾ। ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਸਾਡੇ ਕੋਲ ਹੈਗਾ ਸਮੂਥ ਸੀਮੈਂਟ ਪਲਾਸਟਰ ਜਾਂ ਪਲੇਨਡ ਵੁੱਡ ਦੇ ਵਿੱਚ ਅਸੀਂ k ਦੀ ਵੈਲਿਊ ਜਿਹੜੀ ਲੈਂਦੇ ਆ ਉਹ 0.11 ਹੈਗੀ ਹੈ। ਬ੍ਰਿਕਸ ਹੋਣ, ਕੰਕਰੀਟ ਹੋਵੇ, ਅਨਪਲੇਨਡ ਵੁੱਡ ਹੋਵੇ ਉਹਦੇ ਵਿੱਚ 0.21 ਦੀ ਵੈਲਿਊ ਲੈਂਦੇ ਆ। ਪੂਅਰ ਬ੍ਰਿਕ ਵਰਕ ਹੋਵੇ ਜਾਂ ਸਾਡੇ ਕੋਲ ਰਬਲ ਮੈਸਨਰੀ ਹੋਵੇ ਤਾਂ ਵੈਲਿਊ ਆਫ ਦਿਸ ਇਜ਼ ਟੇਕਨ 0.83 ਲੈਂਦੇ ਆ। ਅਰਦਨ ਚੈਨਲਸ ਹੋਣ ਇਨ ਵੈਰੀ ਗੁੱਡ ਕੰਡੀਸ਼ਨ ਦੇ ਵਿੱਚ ਤਾਂ ਇਹਦੀ ਵੈਲਿਊ ਅਸੀਂ 1.54 ਲੈਂਦੇ ਆ। ਅਰਦਨ ਚੈਨਲਸ ਆਫ ਐਵਰੇਜ ਕੰਡੀਸ਼ਨ ਦੇ ਵਿੱਚ ਦੀ ਵੈਲਿਊ ਆਫ ਕੇ ਜਿਹਨੂੰ ਅਸੀਂ Bayesian's constant ਕਹਿੰਦੇ ਆ ਉਹਦੀ ਵੈਲਿਊ 2.36 ਹੈਗੀ ਹੈ। ਥਰਡ ਵਨ ਅਰਥ ਆਫ ਦੀ ਰਫਨੈਸ ਸਰਫੇਸ ਦੇ ਵਿੱਚ ਵੈਲਿਊ ਆਫ ਦਿਸ ਕੇ Bayesian's constant ਦੀ ਵੈਲਿਊ 3.16 ਹੈਗੀ ਹੈ, 3.17। ਉਸ ਤੋਂ ਬਾਅਦ ਸਾਡੇ ਕੋਲ ਸੈਕਿੰਡ ਫਾਰਮੂਲਾ ਹੈਗਾ Chasey constant ਕੱਢਣ ਵਾਸਤੇ ਜਿਸ ਨੂੰ ਅਸੀਂ ਕਹਿੰਦੇ ਹੈਗੇ ਆ ਜੀ Coutillard's formula। ਦੀ ਸੈਕਿੰਡ ਵਨ ਇਜ਼ ਬਾਈ Coutillard's constant ਜਾਂ Coutillard's ਫਾਰਮੂਲੇ ਦੇ ਮੁਤਾਬਕ ਜਿਹੜਾ Chasey constant ਹੈਗਾ ਉਹ ਅਸੀਂ ਕੈਲਕੂਲੇਟ ਕਰਦੇ ਹਾਂ। ਸੋ ਇਸ ਦੇ ਵਿੱਚ ਜਿਹੜਾ Coutillard's ਫਾਰਮੂਲਾ ਹੈਗਾ Chasey constant ਦੀ ਵੈਲਿਊ ਜਿਹੜੀ ਹੋਏਗੀ ਉਹ ਡਿਨੋਮੀਨੇਟਰ ਦੇ ਵਿੱਚ ਇਹ ਰੱਖਦੇ ਹਾਂ ਔਰ ਡਿਨੋਮੀਨੇਟਰ ਦੇ ਵਿੱਚ ਅਸੀਂ ਇਹ ਰੱਖਦੇ ਹੈਗੇ ਆ। ਸੋ ਐਟ ਦੀ ਟੌਪ ਵਨ ਵੀ ਕੀਪ ਇਨ ਦੀ ਨਿਊਮੀਰੇਟਰ that is 23 plus 0.00155 divided by I plus 1 by n, ਇਸ ਨੂੰ ਅਸੀਂ ਡਿਨੋਮੀਨੇਟਰ ਦੇ ਵਿੱਚ ਰੱਖਦੇ ਹਾਂ। ਇਸ ਨੂੰ ਟੋਟਲ ਨੂੰ ਅਸੀਂ ਡਿਵਾਈਡ ਕਰਦੇ ਹਾਂ ਡਿਨੋਮੀਨੇਟਰ ਦੇ ਨਾਲ ਔਰ ਡਿਨੋਮੀਨੇਟਰ ਦੀ ਵੈਲਿਊ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਉਹ 1 plus 23 plus 0.00155 divided by n I divided by I ਨੂੰ ਮਲਟੀਪਲਾਈਡ ਕਰਦੇ ਹਾਂ n divided by under root m ਦੇ ਨਾਲ। ਸੋ ਦਿਸ ਇਜ਼ ਫॉर ਦੀ ਨੂਮੈਰੇਟਰ ਐਂਡ ਦਿਸ ਇਜ਼ ਫॉर ਦੀ ਡਿਨੋਮੀਨੇਟਰ। ਸੋ ਇਹਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਕੁਝ ਵੈਲਿਊਜ਼ ਨੇ ਜਿਸ ਤਰ੍ਹਾਂ ਦੀ m ਦਿਸ ਰਹੀ ਹੈ, i ਦਿਸ ਰਹੀ ਹੈ, n ਦਿਸ ਰਹੀ ਹੈ। m ਨੂੰ ਅਸੀਂ ਪਹਿਲੇ ਹੀ ਕੈਲਕੂਲੇਟ ਕੀਤਾ ਹੋਇਆ ਹੈ ਜਿਹਨੂੰ ਅਸੀਂ ਹਾਈਡ੍ਰੋਲਿਕ ਮੀਨ ਡੈਪਥ ਕਹਿੰਦੇ ਹੈਗੇ ਆ, i ਨੂੰ ਅਸੀਂ ਹਾਈਡ੍ਰੋਲਿਕ ਗ੍ਰੇਡੀਐਂਟ ਕਹਿੰਦੇ ਹੈਗੇ ਆ ਔਰ n ਨੂੰ ਅਸੀਂ Coutillard's constant ਬਿਕੋਜ਼ ਇਟ ਇਜ਼ ਏ Coutillard's formula ਫॉर ਕੈਲਕੂਲੇਟਿੰਗ ਦੀ Chasey constant। ਸੋ ਇਹਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਇਹਦੇ ਵਿੱਚ ਵੀ ਉਸੇ ਤਰ੍ਹਾਂ Coutillard's constant ਜਿਹੜਾ ਹੈਗਾ ਉਹ ਸਾਡੇ ਕੋਲ ਕੁਝ ਸਰਫੇਸਿਸ ਦੇ ਨਾਲ ਕੰਟੈਕਟ ਦੇ ਨਾਲ ਡਿਪੈਂਡ ਕਰੇਗਾ। ਸਮੂਥ ਸੀਮੈਂਟ ਪਲਾਸਟਰ ਵਿੱਚ ਜਾਂ ਪਲੇਨਡ ਵੁੱਡ ਦੇ ਵਿੱਚ ਇਹਦੀ ਵੈਲਿਊ ਜਿਹੜੀ Coutillard's constant ਹੈ ਉਹ 0.010 ਹੈਗੀ ਹੈ। ਬ੍ਰਿਕਸ ਹੋਣ, ਕੰਕਰੀਟ ਹੋਵੇ ਜਾਂ ਅਨਪਲੇਨਡ ਵੁੱਡ ਸਰਫੇਸ ਹੋਵੇ ਉਹਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਇਹ Coutillard's constant ਹੈ ਉਹ 0.12 ਦੀ ਵੈਲਿਊ ਹੁੰਦੀ ਹੈ। ਪੂਅਰ ਬ੍ਰਿਕ ਵਰਕ ਹੋਵੇ ਜਾਂ ਰਬਲ ਮੈਸਨਰੀ ਵਰਕ ਹੋਵੇ ਤਾਂ Coutillard's ਦੀ ਕੌਂਸਟੈਂਟ ਸਾਡੇ ਕੋਲ k ਦੀ ਵੈਲਿਊ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਉਹ 0.017 ਹੈਗੀ ਹੈ। ਅਰਦਨ ਚੈਨਲਸ ਹੋਣ ਇਨ ਵੈਰੀ ਗੁੱਡ ਕੰਡੀਸ਼ਨ ਦੇ ਵਿੱਚ ਜਿਹੜਾ Coutillard's ਕੌਂਸਟੈਂਟ ਹੈ ਉਹਦੀ ਵੈਲਿਊ ਸਾਡੇ ਕੋਲ 0.20 ਹੈਗੀ ਹੈ। ਅਰਦਨ ਚੈਨਲਸ ਆਫ ਐਵਰੇਜ ਕੰਡੀਸ਼ਨ ਦੇ ਵਿੱਚ Coutillard's ਦੀ ਕੌਂਸਟੈਂਟ 0.025 ਹੈਗੀ ਹੈ। ਅਰਥ ਆਫ ਦੀ ਰਫਨੈਸ ਸਰਫੇਸ ਦੇ ਵਿੱਚ ਹੈਗੀ ਹੈ ਦੀ ਕੁਟੀਰਸ ਕੌਂਸਟੈਂਟ 0.030। ਇਸ ਤੋਂ ਬਾਅਦ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਤੀਜਾ ਫਾਰਮੂਲਾ ਹੈਗਾ ਚੇਜ਼ੀ ਕੌਂਸਟੈਂਟ ਕੱਢਣ ਦੇ ਵਾਸਤੇ, ਦੈਟ ਇਜ਼ ਨੋਨ ਐਜ਼ ਦੀ ਮੈਨਿੰਗਸ ਫਾਰਮੂਲਾ। So it is the simplest formula and more commonly used for the uniform open ਚੈਨਲਾਂ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਅਸੀਂ ਜਿਹੜਾ ਮੈਨਿੰਗਸ ਫਾਰਮੂਲੇ ਨੂੰ ਜ਼ਿਆਦਾ ਯੂਜ਼ ਕਰਦੇ ਹੈਗੇ ਆ। ਇਹਦੇ ਵਿੱਚ